Hello students, today we are going to discuss the fourth numerical of analysis of truss by method of joint. Question is shown in the screen that find the forces in each member of the truss. Now we need to find the force in each member of the truss which is shown on your screen. Now joint A is having hinge support, joint D is having roller support. At joint B there will be a 10 kN force acting in the downward direction, and at C there will be a 5 kN load acting in the downward direction. Now we need to find the forces in each member of the truss. If member ABBC is of 2 meter length, similarly member AD is of 2 meter length. Now from the conclusion drawn in the previous question, we just move with the conclusions portion. Okay. Now if the horizontal and vertical lengths are equal, then it will be of 45 degree. Then this angle will be of 45 degree. Now if 5 kN force is acting at joint C in the downward direction, to maintain the vertical equilibrium of joint C, we need to create a equal force in the upward direction. For the upward force creation, we need to make the force in this inclined component like this of 5 root 2 kilonewton. Okay, now in this way we had maintained the vertical equilibrium of joint C. To maintain the horizontal equilibrium of joint C, we need to make a force of 5 kilonewton here, which will balance the force of 5 kilonewton due to this inclined portion. Okay, now in this way we had maintained the horizontal equilibrium of joint C. Now to maintain the equilibrium of member BC, we need to create a force of 5 Newton in this direction. Now at joint B, there will be a horizontal force acting towards the joint of 5 Newton in the leftward direction. So to maintain the equilibrium or the horizontal equilibrium of joint B, we need to create a force in this direction to maintain the horizontal equilibrium of joint B. Now to maintain the horizontal equilibrium or to maintain the horizontal equilibrium of joint A, we need to create a force here. Okay, to maintain the member equilibrium of AB. Now at this joint there will be a horizontal force of 5 kN. Okay, now at joint B, to maintain the vertical equilibrium, a downward force of 10 kN will be acting like this. To maintain the vertical equilibrium, we need to create a force of 10 kN which is of equal magnitude in the upward direction. Okay, now to maintain the equilibrium of member EB, we need to create a force in this direction which will be like this. Okay, now at joint E, there will be two known forces, that is 10 kilonewton away from the joint as well as 5 root 2 kilonewton away from the joint. Now to maintain the horizontal equilibrium or to maintain the vertical equilibrium of joint E, there will be 5 kilonewton force due to this inclined component and 10 kilonewton force due to this vertical component acting in the downward direction. So the total magnitude of force which will be acting in the downward direction at E will be equals to 15 kilonewton. Now to balance this 15 kilonewton downward force, we need to create an upward force. So we had made an upward force like this in the inclined member AE in the upward direction of 15 root 2. Now due to the horizontal component of this inclined member of 15 kilonewton as well as due to the horizontal component of this inclined member EC of 5 kilonewton, net horizontal force acting at joint E will be of 20 kilonewton in the rightward direction. To maintain the equilibrium of joint E, we need to create a 20 kilonewton force in the opposite direction like this. Now to maintain the equilibrium of the member DE, we need to create a 20 kilonewton force like this. Now at joint D, there will be only one horizontal force acting in the rightward direction. To maintain this joint equilibrium of D, we need to create a horizontal force of 20 kilonewton like this. Okay, now at joint D, there will be no vertical forces acting in the vertical direction. So the total vertical force acting in the member AD will be equals to what? 0. Now to maintain the equilibrium of member AE, we need to create a 15 root 2 kilonewton force like this. Now at joint A, there will be two horizontal forces. One will be because of this inclined component A, which will be of 15 kilonewton magnitude, and one will be because of AB member, which will be of 5 kilonewton magnitude. So the total magnitude of force acting in the horizontal direction will be equals to 20 kilonewton in the leftward direction. So to maintain the horizontal equilibrium of joint A, we need to create a rightward force of 20 kilonewton magnitude. Similarly, if we consider the vertical equilibrium of joint A, then the total vertical force coming at joint A is of member AE of 15 kilonewton magnitude. To balance this force, we need to create an upward force of equal magnitude. So at joint A, there will be a 15 kilonewton force acting at joint A in the upward direction to maintain the vertical equilibrium of joint A. In this way, we had calculated all the member force of the truss. That is all about this numerical. Thank you very much, students.